we want to talk about this substitution rule, right? Or substitution method for this conversation function, integrations of a conversation function. For our Cut 1, right, for LA District Community College, this is what we're going to be doing. But a lot of colleges, they use the transcendental, right, early transcendental calculus in Calculus 1. What does that mean? Early transcendental is basically transcendental functions are the exponentials, logarithms, natural logarithm, natural exponential, those kind of things, which you're going to see it in the beginning of Cal 2 and then continue learning different techniques of integrations. Okay? So this 4.5 is a key method that you need to be really, really well, so that when you talk about other different techniques of integrations, then you can basically use this between steps. Okay. So what is this substitution we're talking about? Because if we are talking about a composition functions, okay, let's say if you have integral from f of x, the input is g of x dx, something like this. If your function is a composition function, you're taking integral of the composition function. What happens is we don't know how to take antiderivative of this composition function, because we never learned it. But what we can do is we can take antiderivative of a function f by itself, if it is a good function within our formula range. That's all what we're going to look at in here, okay, within our formula range. So the idea right here is, okay, to rewrite this function as f of some easy input, like we always have f of x. But in this case, we will be talking about f of u. Why? Because that u is going to represent this what? G of x function. And because of your substituting with u and the variable changes, the integral of the variable changes, then this, right, dx needs to change it also to what? Du, because you are talking about now integrating with respect to a different variable. So what happened is, how do I, it's easy to substitute g of x with u, because all you have to say is that u equal to g of x. But how do I substitute, how do I change this, the variable of integrations, right? Integrals, variable integrations. How do we change that? So what happens, what we do is this, we know that this is basically derivatives. So we can take derivatives with respect to u, right? Derivative of u with respect to x on both sides of the function. So that will become like this. So, and using from what we learned in differential, this is basically talking about what du will be equal to g prime of x. So now we can substitute what this dx, right, with du. We have a relation between du and then what? Dx, right? Do you see that? We have a relationship. But however, they are still missing. What is missing? I'm missing this factor right here, derivative of the function that we are substituting. So in the substitution methods, this is what we are looking at in the key part. So pay attention to this. So that way it will help you to look at which function you need to let u be equal to, so that it will fall out nice and neat. And that will require a lot of practice for you to see it in the first place, okay? And being able to substitute. You're going to be doing a lot of trial and error, okay? You're going to be doing a lot of trial and error in some of the cases, more difficult ones. So, method, this is what it says, right? Make it a little bit bigger. So, on a substitution method, if you are integrating the composition function, then we're going to let u be equal to g of x, the inner function, if there is a factor that is taken derivative, there is a factor in the integral that is what? Derivatives. So that I can easily substitute that du with what? Dx, that relation. See that right here, what I'm showing to you right here, I'm missing that g prime of x part. So when you substitute it, that will be still a problematic. And I will show you sometimes how to manipulate those kind of situations. Okay? There are problems that you can manipulate it, but there are problems that you cannot manipulate. But the key point is when you are thinking about what to substitute for, okay? And that's what you need to pay attention. If you think about a function, let a function be equal to u, then you also need to think about derivative of that function. And right away, is there a factor in the integrand is derivative of that functions? Follow so far? So that's the technique that we're going to be looking at. Okay? And when you take the integral of that, after you substitute it, notice that this becomes a nice and neat integral functions that we already know, which is basically what integral is antiderivative of this function. So therefore, integral of f of u du is basically antiderivative of function f with respect to u plus what? C, a constant. And we're going to talk about definite integral as well in our example. Okay? So here's a substitution rule, right? The strategy. So first, you're going to have to decide the reasonable substitution, which is u equal to g of x. So like I said, how do I decide which portion of the integrand you're going to let u be equal to? What you need to do is you need to think about a change, okay? Right. You need, after you think about substitution of u with g of x, then right away you have to think about what is the derivative of that function. And is there, in an original integrand, is there a factor that is g prime of x? And once you get that, then that means you basically make your substitution correct. Sometimes you need to substitute it twice in order to be able to take integrand. So I don't think we can look at that kind of problem right away at this point. Okay. So, any questions on this idea? All right. So, example number 1. My question to you is, where is my composition function in the integrand? Is there any composition function for me? So that's the first question that you need to ask at this point, right? Because you want to start from the easy type and then move on. So in this case, I can basically see that a composition functions in the integrand is this part right here. Square root x to the third power plus 1. So outer function is square root functions and inner functions is x to the third power plus 1. So that sort of gives you a guideline, right? Thinking that I'm going to let u be equal to x to the third plus 1. So right away, I have the derivative of this function because I have an extra factor. And would I be able to nice and neatly substitute that factor? So when I take derivatives respect to x on both sides, that gives me 3x to the second power. And using the differential idea, I can say that du is equal to 3x squared times with x. and dividing 3 on both sides. Now I can see that this x squared, that part, and then dx, that can be substituted with what? 1/3 du. Notice that not all the time when you take the derivative, it will give you right away what you want, right? Well, you can substitute. Notice that right here, I have to what? Write it into differential first, and rewrite it step by step, and then divide it by 1/3 on both sides to get to the situation that we want. Is there any questions before I move any further from here? So if you feel this is smooth, because I'm trying to guiding you through so that you can see right away what is the function that I need to substitute for. So right here, we are okay with this, right? I can move on. Right. So this gives us integral square root of now x to the third plus 1, that is what? Substituting with u. And x squared dx, that will be substituted with 1/3 du. Now we have the integrand, 1 square root of u, and then we are integrating for what? The variable of u. So everything's nice. So using the integral property, bring it out 1/3, rewriting this into 1/2 power d, which is the power functions now, right? Such that I know how to take antiderivative of this. So when I take antiderivative of that, that will become what? Adding 1 to it, 3/2, and divided by 3/2 plus constant. So simplifying it, right? Simplifying it, our final answer become multiplied by reciprocal, so it'll be 2/9 u to the 3/2 plus constant. This is the indefinite integral, so you need to add constant because you will get the a general, right, indefinite integral functions, which is antiderivative functions. Now, you cannot stop right here because the original problem is with the variable of x, a function of x. So now I need to substitute back for the original problem, which is, in this case, that will be 2/9. My u, that is simply x to the third, plus 1, right? My u is x to the third plus 1, and then what? To the 3/2 power plus a constant. And this will be my final answer. So you need to write very neatly, right? So first, on a given integral, think about which technique to use. And if you decided to use, and this problem needs to use this substitution method, you clearly need to show me what are you representing for the u, or with another variable, doesn't matter. And then you need to show me all of this stuff, the manipulations and how you must put it together. Questions, difficulties before we move any further from here? Are we all okay with this?
Can you slow down a little bit?
Oh, sure.
Okay.
Good. So let's take a look at on example number 2. Okay. integral of secant squared 5x dx. So my question to you now is, this is clearly a composition function, right? A composition of 3, actually. See that? So what about is what you're going to substitute for you, with you. That's what we need to think about. So, Ashley, you here? Ashley, are you here? Okay, someone just signed in, I guess. Cynthia, are you here?
Yeah, I'm here.
Okay, so now my question to you is, what you're gonna let u be equal to?
No, 5x.
5x? Why?
I don't know.
Okay, so guess it right. So this is a composition of 3 functions, which is a square function, secant, and then the last will be 5x. Okay. So how do I know like what to substitute for? Okay. So that's really depends on like some of the antiderivative formula that we already learned that you really need to know and remember, so that you can recognize this one. Integral of secant squared x. That will help me to get what? Tangent x, because derivative of tangent is secant squared. Right? Integral of secant squared x, that is basically antiderivative of secant squared x. That will give me tangent x. So although this is a composition of 3 functions, you need to look at as only 2, which is secant squared and then 5x. So my inner function in this case, I have to use what? 5x. Are we all clear on this? Good, right? Okay. So this is very crucial sessions. Okay. Now I have to right away think about the derivatives respect to x of this, which is going to be derivative of 5x. That will be just what? 5. And notice that right here, I don't have a factor of 5 at all, but we don't need to worry about that because we already saw how to manipulate on this extra constant factor that we have. Right? What are we more interested in and more worried about is when there is like a factor with an expression. So this I can basically look at as what? Du equal to 5 dx. So therefore dx is basically what? 1 over 5 du. I can simply start substituting to get nice neat function that we need, which is secant squared u, and times with, for dx, I'm going to be substituting with 1 over 5 du. So when we take the integral, simplify a little bit using the properties of integral, that will be 1/5 integral of secant squared u du, which is the integral of secant squared u is tangent u plus a constant. And finally, substitute back what we originally have, which is 1/5 tangent of u, which in this case my u is 5x. And that will be my end of this problem. Questions? Difficulties? Are we all okay with this? So now, the next question is example number 3. How do we do this problem? You need to substitute. And how do we look at our composition function? So notice that we want to simplify it to a composition of function of 2, even though sometimes you will see that, like in example number 2 that I pointed out, there is a composition of 3 function that we can look at, right? But we want to keep it simple as 2 because we don't want to go that far. So integral of x squared plus 1 to the 20th power of dx. Good. So once again, you need to think about this. Clearly, there is a composition functions involved, right? You can see that. And this is also a product. Remember, we don't know how to take integral of product of 2 functions either, right? But hoping that, seeing the composition function first, hoping that by doing the u substitution, that product will go away. Right? We will be able to rewrite it without product. So, now the question is, what should I let u be equal to, right, in this questions? So once again, can I give Ashley a chance again? Ashley, are you here?
Yes, I'm right here. I'm sorry. It's because I didn't want to put myself on.
So my question to you is, all right, what is the substitution that you need to make? What do you want let u equal to in this case?
Wouldn't it be? Would it be the x squared plus 1?
Okay, x squared plus 1. Are we all okay with this? Right? So yes, right here, that is the composition function part, right, in the integrand. So now I still have what? This portion x right there. So we need to right away think about, right, how do I manipulate with this? So taking derivatives with respect to x. So that will give me 2x, right, plus 0. So I don't need to write it. So therefore, I can basically what? Rewrite it as in the differential idea. Right? Du is equal to 2x times dx. And dividing both sides by 1/2, right? I should say, that basically give us what we want. X, a factor, that's right here, and then dx, so that we can nice and neatly substitute that. Are we all okay with this?
Yes.
So now, continuing this, that will be the integral of, this will become what? U to the 20th power, right? To the 20th power. And times with this x and then dx will be substituted with 1/2 du. So we have integrands. Our integrand is a variable, a function with u, and we are integrating what? A variable of u. So everything's now neat. And we change it into what? A simple, right, exponent of power function. So using the properties of integral, factor out 1/2. Now taking the antiderivatives, integral of u to the 20th power, that will become u to 21 divided by what? 21 plus a constant. So simplifying this, and then substituting with the original variable, that would be 1/42. And this will be what? U to the 21st power, which is basically x squared plus 1 to the 21st power plus a constant. And this will give us our final answer for this indefinite integral. Questions, difficulties before we move any further? Okay, I'll give you a few minutes. Yes, go ahead.
How did you go from that second line, U to the 20th, and then the line to the U to the 21st to the 21?
Oh, when you're taking integral, right, from fundamental theorem of calculus part 2 or part 1, is basically integral is basically what? The antiderivatives.
Correct.
That's the relations that we see. So we are taking antiderivative of these functions u to the second 20th power. How do we
Oh,
take?
I just thought.
Sorry?
I just realized it
Okay,
as you were
good,
saying.
good. Right. So now you see how I go, right? From here.
Yeah.
Okay.
Yep.
So because of this is a power function, we basically use what? Antiderivative formula for the power function.
Good.
We all good? Okay, so do number 4, right? I'll give you a few minutes to head start. And we have more example with less students, so that means you will have a chance for more. Okay, so let's start on this one. As usual, there is a composition functions involved, right? And we want to look at what should I substitute for, so that u be equal to what? So at least I can get this part, I'm hoping, right? So Jennifer, are you here?
Yes.
So where should I let u be?
X plus 9.
X plus 9. Good. So that will give me du dx with respect to x on both sides, which give us what? 1. So that give us du will simply equal to what?
Negative cosine. Oh wait, du would be
Right?
Yeah.
So now continuing back to the problem, substituting, that'll give me sine of g times with du is basically what? Dx, so I substituted it. And what did you say? Integral of sine u?
Would be negative cosine u.
Okay, negative cosine u. And if you just leave it like that on the test, you will lose at least half the point. Don't forget, this is a general, okay, this is an indefinite integral, so you will get a general antiderivative functions. So that will be a c. And finally, we substitute it back with original variables that we have, right? Which is going to be what? Negative cosine x plus 9 plus a constant. That will be final answer.
Wait, can you repeat what you said? The answer in what way it's going to be?
If you forgot to put this plus,
The constant?
yes.
Okay.
Because the question is asking you to evaluate this indefinite integral. So when you evaluate indefinite integral, that will give you a general function, right? Because derivative of this cosine, negative cosine u will give me sine u. But however, it will be also true with a different plus a constant piece. So you need to give me a general. Okay with this?
Yes.
So number 5. So work on number 5 right now. Hopefully by doing this, you already learn by the end of this example. Okay? And so that you can start your homework and then finish it up and study for the test. Our test is next week. We are done with chapter 4 today. So this is how I will start this problem. Look ugly, rewrite it. So this will be basically dx. I will look at this as 1/3 x minus 8 to the negative 5 power. Are we all okay with this?
Yes.
So how many of us tried it this way?
I did it with 1 over 1/3. Move the dx to the side, and then I try to take out a constant.
Take out the constant, like 8?
So, yeah, no, I took out, on the bottom, I took out 1/3, and I got left minus 24.
That's okay also. But, you know, what's going to happen is like, you know, it will become a 3 and you're going to have a factor 3. But that doesn't really like, you know, help us to get to the point that we want. Right? Because like what she's saying is like, you know, looking at this way, 1/3 x minus 8 to the 5th power dx. First write it like this and then factor out 1/3. So it becomes x minus 24 to the 5th power. Okay. Now there is a mistake to it right here. Because when you factor out 1/3, you're not just factoring 1/3 out. You need to factor 1/3 to the 5th power. Because that is inside the 5th power. You see that? So if you just factor out 1/3, then there's a mistake right there. Got my point? And that really doesn't help us because we're still going to have what? This rational expressions and such that we don't know how to integrate of this rational expression. Follow?
Yeah.
Okay. So it's a good idea to, at this point, because we don't know how to simplify rational expressions yet, we can basically rewrite into negative exponent. Now, not necessarily all the time that we will need it, right? We will need that. So from here, now you can see that this is a composition function, right? That's my composition function. So I'm going to let u be equal to so
1/3 x minus 8.
say that again.
It's going to be the 1/3 x minus 8, right?
Yes, 1/3 x minus 8. So right away, I need to think about the derivative of these functions because I have to replace this dx. So this will become 1/3. When you take derivative, that will be 1/3. So now I can basically what? Simplify. Du will be equal to 1/3 dx. And we only have dx, no other extra factor. So therefore, I can manipulate this constant by multiplying both sides by 3. So now, we basically get what we want. So that will be u to the 5th power. And dx will be replaced by 3 du. It's good. So according to the properties of integral, I can factor this 3 out and then integrate the u to the negative 5th power. So add 1 and divide it by that number. And then don't forget to plus the constant. So this will give us, after substituting with the original variable, negative 3/4 times with u to the negative 4 power plus a constant, but our u will be what? 1/3 x minus 8. Are we all okay with this? Any questions? Difficulties? Now, let's do number 6. So try number 6.
In something like this, we would use the 2x, right? Because it's the common one they both have.
You can try it out, right? You can try it out what you think that u be equal to, and then you will see that after you substitute it, if the function that you are trying to integrate, right, does not make it easier, then your substitution basically is not working.
Okay.
And that's what I'm talking about. You know, you're gonna try and a lot of doom, trying and error, because there will be like, you know, a function, something like this that you don't see before, right? Not obvious as the other examples. So right here, which one you look at it, there's like, you know, composition functions right there. Not only one, two. So you need to think about slightly difference, or like, you know, how do we continue right from there? So try it out. So, Paul, what did you let u be equal to?
I'm still stuck on the sine square. Do we need to rewrite that as 1 minus cosine over 2?
1 minus cosine over 2. No, that's not the identity. That's not the identity. Sine square is 1 minus sine square 2x is 1 minus cosine square 2x. And even though you rewrite it, that's not going to help us to go further from there, right? You still have the power. So you couldn't decide what your u is, right? Did you try something?
Well, the u would just be the 2x.
So if you just think about 2x, that on here, right? Then my du is basically what? 2, right? Du dx is 2. So therefore du will be equal to 2 dx, which is dx is equal to, because of I don't have a factor to it, that will be 1/2 du. But take a look at right here. If you substitute this, that will be sine square u cosine u 1/2 du. Now, not going to help us anything because I still don't know how to take the integral of this function right here. Do we all follow so far what I'm finding out? So the key thing is after you substitute it, it will come down to something that we know how to do the integral. Right? We know how to integrate. So anybody try anything else other than u equal to 2?
I tried rewriting it actually to integral sine of 2x times sine of 4x dx, but I'm not getting much further either.
Okay.
U equals cosine 2x.
U equal to cosine 2x. Okay, so let's look at that. So du dx. Now I have to take the chain rule. Derivative of cosine is what? Negative sine x, sine, right? 2x. And derivative of inside is what? 2. Okay with that? Are we all following so far? So now if I rewrite it, that will be du is equal to negative 2 sine 2x times with what? Dx. So I can bring this negative 2 to the other side by dividing it. So now when we substitute it, take a look at it. This cosine will be u. And I can basically take it out one of the sine and then dx, one of the sine and dx, by this, which is going to be negative 1/2, because remember, sine squared 2x is like sine 2x, sine 2x, right? And one of them can be replaced by what? 1/2 du. But we still have what? This right here. So we still have this problematic part. Are we all following so far? What I'm finding out.
Yeah.
So this is a good approach, but if you approach it this way, then you're very close to what you should be doing already. You should see that from this approach right there. Write it down. Okay. I'm going to look at my composition functions right here. Looking at composition function as square functions, and the inner function is sine 2x. Because when we take the derivative of sine, that will be what? Cosine, something that we can have right here, the factor. And remember, since in the beginning I point this out, right? When you let u be equal to, right? And making sure that your du, right, your derivative of u is basically what? There will be a factor in the integrands. Right? There will be a factor in the integrands, so that we can substitute it back nice and neat. So, are we all okay with this, what I pointed out right here, my composition functions?
Yes.
So you're gonna be like, you can see that what I'm pointing out, like don't afraid to write it out, okay? Because when I was learning this, like, I always like, probably we have the same idea. I'm gonna think about in my head and get the right things in the first place. Probably that's not going to happen until you do tons of problems, okay? So by trying out, that will help you to see something that doesn't work, so that it will help you to think about better next time when you're doing similar problems or even more difficult problems, okay? So now you see what I'm doing right here, right? My composition function, I'm going to be looking at for what? Sine squared 2x. Looking at this as a composition functions of x squared and then sine 2x. So now I can say that let u be equal to sine 2x. Excuse me. So du dx, taking derivatives. Derivative of sine is cosine. And then chain rule, so taking derivative inside will be times 2. So this gives us du is equal to 2 cosine 2x dx. And what we have is cosine 2x and then dx. So I'm going to divide both sides by 2 so that we have a relation between du and dx. Follow so far? Now, continuing this, that will be integral of u squared, right? And times with cosine 2x dx, that is basically 1/2 du, substituting. So now this is like very neat and easy functions that we know how to integrate, which is going to be 1/2 times with integral of u squared du. And when I take the integral of this, it means anti-derivatives. Add 1 and divide by that, plus a constant. And simplify and substitute back, that will be 1/6 times with u to the 3rd power plus c. And so my u is basically sine 2x. So this will be my final answer for this one. Are we all okay with this? Any questions, difficulties?
Would we have to test each one to get the correct, substitution, or it's just something you have to know, or we'll get to know?
Now, see, the key thing that I already pointed out in the definitions, what you need to look for when you substitute it, right? So when you let u be equal, when you let inner function to be equal to u, right away you have to think about the derivative of that functions that you let u be equal to. Is there a factor in the integrands or not? That's what you need to pay attention. So you're gonna have to do derivatives in your head and then try to check. Like for example, like this one, okay? When you say earlier, let u be equal to 2, right away what I think about is, if I let u be equal to 2, what about my du? My du will be 2 dx, because the derivative of 2x is 2. And then that's not going to help you to simplify my integrands right here. So right away, I sort of know that that will not work. And when you talk about like my u will be cosine, that's close, right? When I take the derivative of cosine, that will become what? Negative sine 2x times 2. So I have, the problematic part is what? I have sine squared 2x. I have two of them. But when I take the derivative of cosine, I only get one. So I still have another factor that I don't know how to get rid of it. So to answer your questions, like, would I need to test one by one? Then you will be simply doing like, not enough time on the test. You can do when you're doing homework. You should try that to help you to see like, what went wrong. Right? But the main idea that you want to think about it when you're trying one by one is, if I let u be equal to this, would I have these situations or close to that situations? Then you can try it out in that directions, because it will help you to reduce this integrand to a simpler function. Otherwise, then you will be just like systematically trying everything one by one, not, capturing the whole idea and concept of this technique. Are we all following so far? What I'm trying to point out with her questions?
Yeah.
So now, number 7. Do number 7. What should I let u be equal to in this case?
X to the 4th plus 4x plus 1.
X to the 4 plus 4x plus 1. Are we all okay with this? Jennifer, do you agree with that? I see.
Yeah, that's the one I used.
Okay, so I see your thumbs up first. So now, what about the rest of us? Are we all okay with this?
Yes.
Anybody use something else? Ayana, quiet. What did you use?
I used the same one.
You use the same one? Okay. So let's take a look at on this du dx. When you take the derivative on both sides, with respect to x, that will be 4x to the 3rd power plus 4. So when I rewrite this, that will become what? 4x to the 3rd power plus 4 times dx. But what we have is what? X to the 3rd power plus 1. So what I need to do is what? I need to factor out 4 and then manipulate that. Do we get that far?
Yeah.
So when you divide it by 4 on both sides, and this basically what we want. Are we all okay with this? And my apology, this dx is not at the bottom. It should be in the same level as well. Right? Because that's my function. So now this will become what? The integral of, I'm going to rewrite it 1 over x to the 4th power plus 4x plus 1 to the 5th power times with x to the 3rd plus 1 dx. By substituting this will become 1 over u to the 5th power and times with, so this x to the 3rd power dx, right? X to the 3rd power plus 1 dx is what? 1/4 du. So now, simplifying it to take integral, that will give me 1/4 integral of u to the negative 5th power du, which is 1/4 at 1 divided by that number plus a constant. So this gives us negative 1 over 16, and then to the negative 4th power plus a constant, which my u is simply what? Polynomial x to the 4th plus 4x plus 1. Any questions? All right, number 8. Work on number 8.
I'm kind of stuck on this one. I tried using secant squared as u, but that didn't do much.
Okay. And what about the rest of us?
Is it pi x?
Pi x? Good try, but what about how are you gonna work on this x alone?
Sure.
If it is x, then how are you gonna replace? Then secant squared pi x will just become like secant squared pi u. You're not gonna go anywhere from that one. Do we follow when you try that? Do you follow what I pointed out? Yeah.
Yeah, I was trying to do pi x.
Pi x is not wrong. Okay. The wrong part is this. You are looking at this entire integrand together. That's where the wrong part is. Because if you like to pi x, this is not wrong. Okay. That would be correct for looking at this portion right there. So you don't need to worry about this x substituting. Get my point? So for this one, okay, that's why I put this example. Because a lot of times we will get used to it. Our integrand is only one term. Notice that from example 1 to example number 7, all of our integrand is one term only. Now I give you multiple term. So you need to remember that taking integral of the sum is basically sum of the integral. So I can look at as integral of x dx plus integral of secant squared pi x dx. So for the first integral, I don't need to do any substitution at all. It's straightforward. And the second integral is the one that I need to use what? U equal to pi x, something that we just mentioned earlier. Are we all following so far?
Yeah.
We good, right?
Mm-hmm.
So see, this kind of things that you need to at least see once, like to trigger it, and then later on, like, oh, that would be very like obvious case later on, right? So let me continue this, right? So let u be equal to what? Pi x for the second integral. So my du dx, that will be equal to what? Just pi. So my du equal to pi dx. So therefore, my dx will be 1 over pi du. So now we are basically taking integral of x dx plus integral of secant squared u times with what? My dx will be replaced by 1 over pi du. And then you take integral on what? Each part, right? For each term, you take integral for each term separately. Are you all okay with this? So integral of the first term is very straightforward. You add 1 and then divide it by 2. And plus integral of the second term. Integral of the second term is basically what? 1 over pi integral of secant squared u du. So I can basically look at it as x squared over 2 plus 1 over pi. Integral of secant squared u is basically what? Tangent u. And this is where I'm going to put one constant at the end, because first integral you have a constant, second integral you have a constant, but when you add them up, there's not a constant. So you rather write it down one finally. So this one will be finally replacing with the original variable. That will become tangent of my u is basically what? Pi x. So now my integrand is my integral, which is the general antiderivative function, will be what? Everything in terms of x only. Are we all okay with this? Okay, let's take a look at number 9, because I need to introduce you this number 9. Or do you want to try it? Okay, let's do number 9. And this kind of problem I need to know and practice. Integral of x squared, square root of x minus 1 dx. There are some, integrand that will allow you to manipulate what we have. So obviously for this one, you can see that my compensation function is right here. So right away, I'm going to try let u be equal to x minus 1, the inner function. So therefore, my du over dx, that is basically 1. So therefore, I got du is equal to dx. So what will not help us is basically right here. Right? I have this extra factor. See, my du is equal to dx, so I can only replace to dx with what? Du. But I still have this, right here that I don't know how to deal with it, because when you look at substitution part, that will become integral of square root of, I have x squared, square root of u, and then du, dx is basically what? Du. So we have a problematic on this x squared part. Are you all okay with this? So here's a new technique that I'm going to be showing to you, a new manipulation that I'm going to be showing to you, right? So a lot of times we manipulate it on the derivative equations. In effect, we also can manipulate on what I let u be equal to. So I can basically say that let u be equal to x plus 1. That basically means x minus 1. That basically means u plus 1 is also equal to what? X. This is equivalent equation. Do we see where I'm going? Now I know what is x equal to in terms of u. Something that I cannot substitute right before, now I will be able to what? Substitute now. So this will be look like u plus 1 squared. So that will be my x squared. Questions, difficulties on this manipulation part? See, a lot of times we manipulate it on what? This derivative equations, right? Using the differential. But we also can what? Manipulate on the substitution part. Okay? Because these two are equivalent equations anyway. Are we good? Can I continue?
Yeah.
So now that we substitute everything, hey, look at this. That doesn't really help us anywhere, because I still have what? This compensation function u plus 1 to the second power, right? I don't know how to integrate this part. But this expression is a lot better than the original one because we can basically multiply out this u plus 1 squared, u squared plus 2u plus 1, and then times with u to the 1/2 power. So which means I can distribute this u to the 1/2 power into this polynomial, this trinomial. This will give us a nice, neat function that we can integrate, which is going to be what? This will become 5/2, right? When I multiply it, and plus 2 to the u to the 3/2 plus u to the 1/2 du. Good. So now it's basically integral of sum. We can basically use what? Sum of integral that property. Are we all following so far? Similar expression, but one can be do much more than the other one. So now I can basically integrate what? This entire functions, right? So let me write it out step by step. So this will be 5/2 du plus 2 times integral of u to the 3/2 du plus integral of u to the 1/2 du. Later on, you can jump from this step to this final step. Okay? So this is just for the note purpose to help you to see this properties of integral of sum to sum of integrals. So now this will become add 1, which is going to be 7/2, and multiply by reciprocal 2/7, plus add 1, that will be 5/2 multiplied by reciprocal, which is going to be 2/5, and plus add 1, that will be 3/2 multiplied by reciprocal, which is going to be 2/3 plus a constant. And finally, substitute back with what we originally have, my u. And what is u that we substituted for?
X plus 1.
No, I think x minus 1, isn't it?
Oh,
X minus 1. Yeah.
Yes, x minus 1.
X minus 1. Are we all following so far on this technique? See, now I'm teaching you a new way of So, for this one, clearly this is my composition functions. Are we good? So I'm going to let u be equal to 2x plus 3. Do we agree with that?
Yeah.
So my du dx, that will become just 2. So my du is equal to 2 dx, and which will be 1/2 du equal to dx. So that's only going to help us to substitute right here. Not going to help us to do anything right there. So what I can do is I can use the same idea, right, from the past. I'm going to use this original substitution that we made to help us to manipulate on this x part. The key thing is this x right here. So that will be 3 divided by 2. That will be equal to my x. Now I can substitute for x as well. So now I can rewrite my integral will be 5 times square root of u times with 1/2 du, right? The x is 1/2 du. And for this x, extra x outside, I can substitute with u minus 3/2. Are we all okay with this? Do we get this far?
Yes.
Are we good, the rest of us?
Yes.
So now, what I'm going to do is I'm going to rewrite this, right? 5 1/2 times 1/2 is 1/4, so it will be 5/4 integral of u minus 3 times with u to the 1/2 power du. So this will help us. This will help us simplify a little bit further. That will become distributing it. That will be u to the 3/2 power minus 3 times u to the 1/2 power and u. I have written down enough on step by step such that now you should be able to see this integral of difference is basically difference of integrals. So I'm going to be taking integral for each term. So this will be 5/4 times with integral of the first term, you add 1, which is going to be 5/2, divided by 5/2, so you multiply by reciprocal, minus 3 times, you add 1/2, multiply by reciprocal, 2/3, right? And then plus a constant. So now, when I distribute it, this will become 1/2 u to the 5/2 minus this 3 and 3 reduce it, so that I have 2 left. 2 times 5/4 is 5/2 u to the 3/2, and plus a constant times another constant is a bigger constant, right? Or a smaller constant. So finally, my final answer will be substituting this u with original, what we make it. So my substitution will be what? My u will be equal to
2x plus 3.
Say it again?
2x plus 3.
2x plus 3. Right? 2x plus 3. And that will be my final answer. Are we all okay with this? Any questions? Difficulties? Alright. Then the next example is basically definite integral, right? Using this substitution technique. So we need to write it properly. There's 2 different ways to do it. I'm just going to show a standard.
Sorry, can you just stay in that for a couple of seconds? I'm just finishing. Okay, thank you.
Are we all okay with this now? Can I delete it?
Mm-hmm.
So number 11 is definite integral. That will give us a numerical value now. The integral from -2 to 0 of 2t squared, square root of 1 minus 4t to the 3rd power. So when we look at this integral, we see that this is a composition function. So we're going to let u be equal to 1 minus 4t to the 3rd power. So that will give us du dx, right? Derivative with respect to x on both sides. That will give me -12t squared. So writing it, du is equal to -2t squared d. My bad, sorry. It should be dt because we are changing the variable. I got dragged by the previous example. So make sure you write it carefully. Not dx, dt, because we are talking about a function of t. So the next is we see that, right, the relation between du and dt, but dt I can replace it what right here. 2t squared dt, I can replace it. So what I can do is I can look at this by du is equal to -6 times 2t squared dt. So which is 2t squared dt, that will be basically -1/6 du. Follow? let's make the substitution now. Integral of square root of, now that will be u, right? And times with, we know that 2t squared dt, that is basically negative 1/6 du. Here's the difference between the definite integral and indefinite integral. Indefinite integral, we can just continue like this. Now, definite integral, because of you change your variable, then the limit must be go along with this variable as well. Otherwise, you're going to have to write it as an indefinite integral and then evaluate it with the original variable with original limit n. If you keep on writing like this is wrong. Because this limit, the lower limit and upper limit, is for the variable t, right? The limit of t. Now we already changed it into variable u already, so this limit got to go change also. So technically writing, when you do the substitution already, then you also need to look at your limits. So when t is equal to 0 for upper limit, that means my u is going to be equal to 1 minus 4 times 0 to the third, because my u is equal to what? This, 1 minus 4t to the third power. So therefore, my u will be equal to 1. When t is equal to negative 2, my u will be equal to 1 minus negative 2 to the third power, which is going to be equal to negative 8 times 4, 32, plus 1, right? That will become 33. Are we all following so far?
Do we have to do this step, or can we wait until the end when we plug it back?
You can. Okay. You can. Let me show it to you, like how to write it properly if you're going to be doing that.
Oh.
So this will become, remember your lower limit and upper limits, okay? Will be 1 and 33 right here. So now this cannot happen. We know that the lower limit has to be smaller than the upper limit. So what we can do is we can rewrite this neg of integral of 1, because when you split around the limits, you have extra negative sign. Negative 1/6 u to the 1/2 du. Now I can bring this constant out. That will become, right, that will become 1/6 integral from 1 to 33 of u to the 1 du. So finally, when I evaluate this, the fundamental theorem of calculus part 2 basically help us to do this. U to the 3/2 divided by 3/2, so it will be 2/3. Evaluating from 1 to 3. Simplifying this a bit further, that will be 1/9. Okay. Over 9. U to the 3/2, evaluating from 1 to 3. Because of this limit is for u already, I don't need to change back to our original variable. Otherwise, you're going to have to do that. So this will become 1/9, 33 to the 3/2 power minus 1 to the 3/2 power. And when you simplify this, that will become 1/9. Right? And this is not, you cannot take the square. Square is not a good number, so I'm going to leave in my answer in this format. I'm all okay with this. Because of you change the variable to make it easier for integrating, the limit has to go along with the variable that you change also. Are we all following so far? If you do not write it this way, then there is another way to write it down, but I really don't recommend that. So what you basically do is now it's this. What happened? You can erase this.
Can you slow down a little bit?
You're going along indefinite integral, right? Making sure that you don't put any things from here. So that would be negative sign right there because of you don't change the limits. And that will give us this. And now what you're going to do is you're going to rewrite this negative 1 over 9. U is basically what we substituted, which is going to be what? 1 minus 14 to the third power. So 1 minus 14 to the third power, 3 half power. And then you are evaluating from negative 1 to 0. Is it negative 1 or negative 2? Negative 2. So notice that the same idea, but when you substitute back the original variable, look at these expressions. A little bit more complicated than what we have before. So sometimes, like after you do the U substitution, using that is much easier to go than this route. Right? So you have to be careful because once you write it down your limit as like negative 2 to 0 right here, that's already mistakes. Are we all following so far? So this is how you can write it alternatively. Think of it as like definite indefinite integral, and then putting the evaluation at the end.
I have a question. What was there never a constant added in this case?
Don't need to add. Because when you talk about, right, that constant's going to be gone. So I point this out like last time. Let me point it out again. When you are, when you are integrating, let's say like you have this integral, let's say y squared, right? And let's say you add constant if you are evaluating from 0 to 1. Okay. By fundamental theorem of calculus part 2, you're going to be evaluating the upper limits minus the lower limits. See, this constant is going to be subtracted each other anyway.
Got it.
Right? Because, after you write it down the most general formula, and then when you're evaluating it, this, no matter what the constant is in the most general formula, then when you, subtract it, it's going to be 0. So it doesn't really need to write it down anymore in that sense. So I can add a comment, but once you start working on this, you can see that it will become technical. Are we all okay with this? Right. Example number 12, you can do it by yourself. I'm done with the sessions.